All right, hi everybody. To just start recording, we are going to talk through some data manipulation language today. But before we get to that, let's talk a little bit about what we're going to be doing for the next couple of weeks in terms of our schedule. First thing is that phase 2 of the visualization project is up on eCampus. This is obviously a group-based project, so you'll be able to see it within your groups. It is due not this Tuesday, but next Tuesday, April 1st. And what we're asking for in this case is for the group to come up with at least one visualization that is asking and answering a question related to the topic you guys are planning on pursuing for your final project. So I don't care what visualization you use in Tableau. There are lots of choices. So choose whichever one best illustrates whatever answer you're coming up with for the question that you're asking. I do want you to use a text box to let the viewer know what the question was and also what you think your answer is that you're deriving from the data that you're using. I also want you to use separate annotation to let the viewer know what you're planning on doing next. So now that you've kind of worked through a question, what does that lead you to necessarily, or what would you like to follow up with? So kind of lead us through the first part of your narrative and how you're going to be using Tableau to illustrate both the question and the answer. This means that one person in your group needs to submit on eCampus, not everybody, just one person needs to submit, and the Tableau workbook should be named based upon your team name, and then a dash, and then the fact that this is phase 2. So you can see an example there in terms of the naming. Obviously, feel free to ask me any questions between now and next Thursday as you're trying to come up with this sort of stuff. I'm happy to meet with you guys or talk before or after class, and we can suss through this sort of thing. This is just supposed to kind of get you kick-started into what the rest of what the rest of Tableau is going to look like as you're moving through that final project. So again, this is due next Thursday. So let's just take a look at our schedule. If we take a look at the syllabus, what we're doing today is our data manipulation language. So I'm going to lecture for most of today and kind of demonstrate a few examples of data manipulation language in SQL. At this point, everybody should have your databases set up in SQL Server. And just a reminder, if you are one of the people that is remoting into the lab, please try to reserve those times for either early in the morning or in the evenings, so we don't interrupt any classes that are scheduled inside the lab. On Thursday, we're going to probably talk a little bit more about data manipulation language, and I will be happy to visit with all the groups and kind of touch base about what you're doing with your visualization projects, so at least get started on that. Next Tuesday, we're going to talk through a bunch of the workbook problems that we're doing for this SQL data manipulation language. And there is actually a homework, the very first homework this semester, where you're going to be submitting something on eCampus on an individual basis. So I know in the past we've done a lot of collaborative work. I want you to try to not do that for this next step. I want everybody to try to work through the various SQL questions that are in the workbook and submit both the query and the result of that query in a Word document on eCampus. So if you go to the database folder on eCampus, you'll see that there's an assignment there with some instructions on the particular questions I'm looking for. It's pages 5 through the very top of page 9 in the SQL workbook. Basically the basic queries that I want you to work through. And there are a bunch of them, but a lot of them are really, really easy. So it'll take you a little bit of time just because there are a lot of different queries you have to work through. But again, it's mostly just because of the volume of them. It'll give you a lot of opportunity to practice, but I want this to be individual work. So can you chat with your group mates and say, hey, I'm really struggling with this particular question? Sure, but don't get answers from anybody else. Don't be copying and pasting each other's work. Don't be giving anybody else in the class your answers. I want everybody to kind of work through these questions. It'll be good practice, especially for our SQL exam that's coming up in a little bit. So that's due next Tuesday, which means Tuesday in class, we will spend time reviewing the answers to those questions and clarifying any other data manipulation language questions you might have. And then on Thursday, we'll do breakouts and we'll talk about the visualization project results everybody comes up with. We'll probably do it in the big group actually and have everybody talk about it. April 6th, we'll reserve for getting ready for the exams. We'll do a little bit of an exam review. And then April 8th is our first SQL exam. Now, we do have a potential scheduling issue with the SQL exam, which is, I have quite a few of you that are remoting into a lab, but I want you guys to be only doing that after hours. So I don't think we can have the SQL exam during our normal exam time because we would be knocking some people off their computers in the lab that day. So I think we need to talk about trying to have that SQL exam the evening of the 8th. I will send out an email or something along those lines after class today or the next day and ask people for their input. But I think that it would be best if we try to have that exam maybe 7 o'clock at night on that Thursday so that everybody can participate, even if you're remoting in and we're not interfering with any of the regularly scheduled classes. This wasn't part of our plan, but given what we have to do from a remote environment and how SQL Server is working, I think this is going to be our best bet. So be planning on the 8th of April, not meeting during normal class time, but having an evening exam instead. And if that is a major issue for you, please get back to me as soon as you can so we can figure out some sort of alternative. But I'm going to expect basically official excuses only. If it's just that it's inconvenient, I'm going to ask you to work with me to make this happen, and I appreciate that. Okay, so that's kind of what we're looking at as far as our schedule for the remainder of the next couple of weeks. So let's jump into today's lecture. Let me stop sharing and then reshare.
Professor, just a quick question.
PowerPoint. Yeah, what's up?
So you said to show the results of the query in a Word document. I guess what do you mean by that?
Well, I'm going to demonstrate all that today.
Oh, okay, awesome. All right,
Yeah.
thanks.
That's not what I want. Hold on a second. This one. Okay. So for the remainder of today, we're going to talk through another aspect of SQL, the query language, in terms of how we get information out of our data sources. So this is the data manipulation language. This would assume that you already have all of your data established. You've set up all of your table structures, the relations between the various tables, and you've populated those tables with at least some initial data. And now the question is, what do you do with all of that? So the data manipulation language is using SQL to query a database, ask questions of what's going on inside your data source. The third aspect of the SQL environment would be data control language, where we're managing things like administration privileges, committing data, that sort of stuff. And that's a little bit outside the scope for this class, so we won't really dig into that, but we'll be spending a lot of time on data manipulation language. We're going to start with some pretty basic stuff, and then we'll build out to some pretty complex queries by the time we are done talking about these things. So a couple things. One, you can use SQL, the language, to change the actual data. So for instance, if I wanted to insert additional information into my database, I absolutely could. And I just realized I'm sharing the wrong way. One second. I'm going to want to share my screen so you guys can see what I do in my database. So one way of manipulating data in your database is using an insert statement. And if I jump out of this and copy and paste, I can just drop this query into SQL and run it, and I can accomplish a particular goal. So I'm coming over to my SQL solution. And at the moment, if I go look at my customers table in my CSI database, I've got a bunch of different customers here, 110 different customers. I want to add a customer using SQL. You could easily manually manipulate this. In fact, we did this to get it started by coming down to the very last line where it says null, and there's a little asterisk down here, and start typing some stuff in if you wanted to. So you could manually enter stuff, but if you want to use SQL, you can. I'm going to right click on my database over here on the Object Explorer and choose New Query. And this opens up a blank query window where we can write our queries if we want to. And I'm just going to paste that query in from my slides. So what I'm going to be doing is I'm inserting information into a specific table, it's the customers table, and then I'm inserting specific values. Now, this does mean that I have some insight as to how this table is structured, because I have to put these things in a very proper order. And you can see I'm putting in first a designation, which is the first 3 letters of my last name and the first 2 letters of my first name. So BOO for Boone and then TE for Ted. And then I'm going to insert my last name, Boone. I'm going to insert my first name, Ted. I'm inserting my office and College Station in Texas and all that good stuff. And this is the notation for getting these sorts of things in. So in SQL Server, you do this N to suggest that you are inputting some of this text information. You may have to do a little bit of Googling to figure some of this stuff out. I'm going to go ahead and execute this query. It's something I would only want to do once. And in fact, I'll demonstrate what happens if I do it more than once. If I now try to open up the customers table and show it, you'll see that my name is now in the database. And because the customer ID is the unique identifier, the primary key, it's also indexed. So that's how this data is sorted. So I ended up kind of percolating up to the top 10 or so of this table, but I'm in there with all of my information. So you can use SQL to insert stuff if you want to, but it is often probably a one-time deal. If I try to run this a second time, you'll see that it doesn't work. I actually get an error, violation of primary key, can't insert this object. And it even says the duplicate key is this BOOTE. If you think about it, that is the primary key, so it can't exist more than once. So trying to put me in there more than once is not allowed. And I'd get the same thing if I was trying to manually enter that information as well. The primary key can't be duplicated. That's the very definition of a primary key. So you couldn't run this query more than once. So feel free to use insert statements if you want to. This is an interesting one. This is where I'm going to grab information from one table and insert it into another. So in this case, if I paste this query in, if you look at it, I'm going to insert into a table called TX customers. It's basically the same as the customers table, but it's called TX customers, the exact same structure. It's not linked to anything else. It's just for this demonstration in today's lecture, where I'm pulling this stuff off into a separate table. So I'm grabbing everything from the customers table. That asterisk is a wild card. I'm going to grab everything from the customers table if it meets a particular condition. And that condition is that the region column is equal to TX, surrounded by single quotes. Well, it turns out I'm the only person that lives in Texas that's currently in the customer database. So when I run this query, it's going to insert whatever it found that meets this criteria in the customers table into the Texas customers table. And if I run this, it will work just that one time. And now if I come over to my TX customers table and take a look at it, you'll see that I'm in there, right? If I tried to run that query a second time, I should get an error message because I can't add that primary key a second time in the Texas customers table. So if you wanted to pull a subset of some of your information off into a different table, an insert query might be the right choice. You could go use a select query to go find a specific subset of information, and whatever you come up with, you could use as an insert into a new table and kind of have a subset of information if you wanted to. Kind of an interesting way of using SQL to grab that information. So again, something you're probably not going to do very frequently. This is actually kind of more on the data structuring, right? Because we're adding information to our tables, but still something that might be useful. Other ways that you could potentially manipulate the information inside your database using SQL, you might do things like an update statement. I'm not going to run these, but obviously you could copy and paste these queries and run them if you want to. Here you can see that anywhere where the product ID is equal to 7 should be one place because that's the unique product ID for products. I'm going to set its unit price to $49. So again, if I came over to SQL and I looked at my products table, I guess I could probably run this one. I'll run this one. Why not? And I go to the product that we're thinking about, product 7. You can see that the price here is $49. Well, let's change it to something else. I don't think that's what it was originally. I think I've done this before. So I'm going to enter 25 and hit enter and update that one manually. And then let's run the query to see what happens. I'm going to go borrow this code. I'm going to update the products table, specifically setting the unit price wherever the product ID is equal to 7. Obviously, this could be a bunch of products in some ways. Maybe I set the unit price to 49 for everything where the first letter is a B. There can be all kinds of interesting ways you could do this. I'm just going to run this once. And now if I go back and take a look at my products, I should see for product 7 that I've updated the price to $49. So another way that you could manipulate the data behind the scenes using the SQL language. You can remove information by deleting from a specific table. You could do it with criteria. So here they're going to delete from customer where the customer state is equal to Hawaii. I'd remove all the Hawaii customers. Not going to do that, but it will work. You could also just delete from customer with no criteria, and this effectively deletes everything that's in the table. Now, keep in mind that you may have a situation where you try to delete things and you get scolded, you get an error message because of some of your constraints. If I have customers in my database that are involved in some of my other relationships, and it's going to affect data in other places if I try to either change them or remove them, SQL won't let me do it. It will scold me and say, if you try to delete this, then the order that's connected to this customer will get all kinds of wonky, and the rules won't let you do that, so I'm not going to remove that information. So some of this information I'm providing to you in terms of updating or deleting won't always work based upon your primary key, foreign key relationships, and the various constraints that you may have set up, depending on whether you're cascading changes or allowing for nulls, depending on what kind of rules you set up. These sorts of queries won't always work. And just something to be thinking about. If you get error messages, take a look at the error message and consider why SQL is not letting you accomplish whatever it is you're trying to do. All right. For the remainder of this slide deck, we're going to be dealing with select statements. It is one of the most powerful type of query that we can write. It does not affect the data in any way. So some of the other stuff, obviously, we're adding information, we're changing information, or we're deleting information. The select query does none of those things. All it does is give you a specific view of some set of a table or multiple tables based upon the criteria that you are providing in the statement. So it is a way of looking at some of the data that meets your criteria. And you can do really powerful things with all of these different select statement criteria. And you can see all of them here. I would definitely go back to the slide at a later date, but I'm going to kind of walk through how a lot of these work over the next half an hour or so. So let's take a look at some of these various select statements. Most of the time what we're doing is trying to answer a question. So in this case, I want to find all the products in my CSI database where the standard price is greater than $75. You type select, then you type the names of any of the columns you want to show up in your view. You type where you want to get this information, and it's going to be one or more tables or another query. Potentially another query is the source. And then you type criteria. In this case, the criteria is that our unit price is greater than 75. Okay, so this means strictly greater, which means $75 won't show up, but $75.01 will. So I'm going to copy this and try it over in my query. And I'm going to run this. Keep in mind, it's not going to change any of the data in any way. We're not manipulating our data. We're just looking at it. And this is where the earlier question comes into play. If I am trying to answer the workbook questions for homework, I would want to provide this as the query that I decided to run, and I would want to provide this as the result. And you can copy and paste these or do a screenshot if you want to show this is the query that I ran. And then, I mean, you could even shrink this stuff up if you wanted to get a really nice small screenshot. That'd be fine with me for the homework, where this is what I ran and this is the result that I got. Okay, so here you can see 3 different products. The lawn cart has a unit price that's $85. The weed whacker has a price that's $89, and the garden cart has a price that's more than $125. These are the only products in the product table where the price is more than $75. And we could confirm that. We'll take a look at the top 200 rows for products. And we could take a look up and down the various unit prices. And see, there are a lot of things that are smaller than that. There aren't very many that are expensive, but I can see the one here for 85, and I can see the one here for 89. It's kind of just eyeballing this, you can see there aren't many that are very expensive. Here's the garden cart for 125 bucks. Yeah. So think about, if you are familiar with Excel, how you might use filters, and you could just shrink down the lists in an Excel workbook to only match up with certain numbers or certain ranges. We're doing the same sort of thing with our query language to get a specific subset of our data. In this case, we narrowed the number of rows based upon that where statement, and we narrowed the number of columns we're displaying based upon the select statement itself. We only showed the product name and the unit price. We could show all the columns, we've got to list them all out. We could even do a wildcard if you wanted to. So just very briefly, it could be something like this: select all from products. And if I execute, I'll get all the columns, but the criteria is still the same. The unit price has to be more than $75 for us to show the 3 products. So all kinds of neat things you can do with these select statements. Let's keep working through some examples. This next one, we're going to talk about using a aggregate function. In this case, we're going to select everything from the orders details table where the order ID is equal to 11092. I'm actually going to slightly modify this the first time I run it, and then I'll go back to that count. So bear with me just a second. I'm not going to run what I just pasted. I'm going to show you what would happen if I just did a regular select statement where I get everything from the order details table where the order ID is equal to 11092. Okay. If I execute on that, you can see that order number 11092 includes 5 different products. Right? So this person was busy shopping on Amazon. They ordered a bunch of different stuff. They bought one of a variety of different products, and they bought 2 of that last product, 81, right? And you can see the product ID, the unit price, the quantity, and the discounts for all of those different things. Cool. But this isn't what I want. What I want to know is how many products are in the order details table for order 11092. I want to actually have this thing count it for me. I can manually do it, but I want to have a query do it. Well, if I go back to that original query where I do a count of everything from my order details table, where I meet a particular criteria and I execute, I get that 5. It actually does the calculation for me. And that's pretty cool, huh? Where you can actually count things up. And you don't have to have all these criteria. So for instance, again, if I did a remove here, I'll get the total number of items in the order details. I don't know that's a particularly useful number, but still, you kind of know we've had 159 different line items that are ordered across our various products. So you can do some really cool stuff. I think the original query is probably a little bit better here, where it's for a specific order ID. Sorry. And we get that specific result. Okay, so you can ask all kinds of interesting questions, and SQL Server, SQL language will actually get you some really interesting results. Now, keep in mind, with aggregate functions, you can't have a single value column in the select clause unless you do group by. We're going to see this a little bit later. So I couldn't necessarily have a column that says order ID, because it's trying to do an aggregation where it's trying to count things up. So it wouldn't be able to say 11092 and the number 5. It doesn't work very well unless we add some additional language. We're going to see that in a little bit of a later query. But if you're doing aggregate functions, you may only be able to get just a single number reported to you because you're doing that aggregate function. So maxes, mins, counts, averages, they are just that. They are a single number that you're getting out of the system, and you can't necessarily include individual columns when you're trying to do aggregate calculations. All of SQL will allow for various Boolean operators. So things like ands, ors, and nots are allowed. So let's get this query into SQL Server and see what it does. And then let's talk about, oh, I have an extra S there. Let's talk about what it's actually doing here. I am pulling the product name, the Latin name, and I think the PowerPoint slides on eCampus are slightly different than this. I added the unit price as well. I wanted to see it. From my products table, all of those 3 columns from the products table, where my product name is equal to A, and then that percentage sign. That is a wildcard extension, which basically means it starts with the letter A, and then it's any other number of letters after the letter A. Or product name is like B percentage sign, so anything that starts with the letter B, and then any number of letters afterwards. And the unit price is less than $10. So if we take a look at our list, you can see the product names. I've got a bunch of products that start with the letter A, my autumn crocus and my anise and my Austrian pine. And then I've got a bunch of products that start with the letter B, right? So there's another A and there's some B's. So a bunch of different products that are A's and B's. I have some Latin names for some of them. Some don't have Latin names. That's totally okay. And the unit price less than $10. Well, wait a minute. If I look at this, you can see that this one, the unit price is higher than $10. Same thing for this one, same thing for this one, same thing for these 2. What's happening here? It says that the unit price has to be less than $10. Well, Boolean logic is kind of tricky. In this case, it's asking where the product name is A anything, or, and there's a completely separate question, the product name is like B anything, and the unit price is less than 10. Well, if you look through this list, all of the ones that start with letter B have a unit price less than $10. The ones that start with the letter A may or may not have a unit price less than $10. It read this in sequence, and it basically grouped these 2 as a single and statement, and it was separated by an or from this criteria. Now, that may not be what you want it to do. So if you look on the PowerPoint slides, I do say be careful of operator order. If you really want something like this, you might use some parentheses. I want everything that's either an A or a B. And no matter what, I want the unit price to be less than $10. So adding some parentheses will add some clarity. I could obviously add some parentheses in other places too. Sorry, I had this parentheses in the wrong place. Am I typing this wrong? Yes, sorry. Sorry, product name. That's where I'm putting the first parenthesis. That product name is either like an A or like a B as a starting point. And then the unit price is less than 10. Now watch the list, because the ones where I have these prices that are greater than $10 are about to disappear. If I re-execute, I get a much shorter list. These are only A's and B's, but all of them, all the A's and all the B's, have a unit price less than $10. When in doubt, put the parentheses in to make it crystal clear what the order is. I wouldn't be able to remember that the and superseded the or, but by putting the parentheses in, super clear. If instead of putting the parentheses there, I did this, that's exactly what the first query did. But by putting the parentheses in, there's no doubt what I'm trying to do, right? So adding these parentheses is kind of superfluous, but from a human perspective, it's extremely useful. So when in doubt, put some parentheses in to make it crystal clear what you're actually trying to accomplish. It will be helpful for the reader and helpful for you as you're doing your programming. But you can do all kinds of ands, ors, nots, all kinds of clever stuff. But again, and takes precedence over or. I can't always remember that, so I use parentheses liberally to make sure I'm clear as far as what I'm trying to do inside the language. Next one, let's talk about the order clause. So again, I'm going to paste this over into SQL Server and we'll take a look at what it does. And then we'll talk about the specific coding here. I am picking up the first name, the last name, and the region from my customers table. I have a where clause where the region is in quote MT or quote ID. So either in Montana or Idaho. You don't have to do this specific language. You could do like the previous query, where region is like MT or region is like ID. But if you have a bunch of them, you've got 16 different things you want to list, it starts to get really tedious to type the whole thing out. So this in allows you to type a series of criteria separated by commas inside a set of parentheses. So it's just a little bit easier to type. Either one would give you the exact same result. So whether you want to use multiple like statements or the single in statement, totally fine. The last part here is how it's going to show you that information. In this case, it's sorting by region first, so Idaho at the top of the list, and then Montana. And then within Idaho and within Montana, it is sorting by last name. So you can see that it's alphabetical, Cox, and then Goad, and then Lum. And then it starts over again from Montana, it goes to Bozeman, goes to Ramos. Okay, so this is simply how you are effectively sorting the results. And again, if you're at all familiar with Excel spreadsheets, you know how you can sort one column at a time, or you could go into the sort field and you can sort multiple columns up and down, all that kind of stuff. You can do the same thing in SQL Server. And there are ascending and descending. I invite you to go do a little bit of Googling to figure out any additional sub-components to any of these queries. You can easily find this stuff because SQL Server is an extremely popular platform. So if you're trying to do something that I haven't done in the PowerPoint slides exactly, you can go figure that stuff out. I guarantee you can just Google this stuff and find lots of resources out there. Nope. All right, let's talk about the group by clause, because this one can get kind of complicated. This allows for what we call scalar aggregates, like we're coming up with a single value with an aggregate function, or vector aggregates, which sounds so fancy, but what it basically means is sub aggregates. So think about, I want to figure out the total for all these different groups, not the total for the entire table, but the total for various criteria. If you do pivot tables at all in Excel, you've done something like this, where you group by a particular column and then you do subtotals for that particular set. Group by is basically doing similar sort of thing. So let's try this query and see kind of what the result looks like and talk about what the language is trying to accomplish. I am selecting a single column from my table, region, and I'm selecting a aggregate function, the count of the region. What I'm asking it to do is basically count up each region, but for each region category. So if I wanted to do just an overall count of the region, I could remove this thing, and I could remove this thing, and I could just tell you how many regions there are in the customers table. There are 111 different regions. That's not what we're asking for. What we're asking for is, for each region, how many are there? This is a super interesting question. It's a question we ask all the time. I want to know, for each region, how many of them are there? And when I execute this, you can see the various regions and how many we got as a count. So you can see for BC, there are 11 of them. For CA, there are 11 of them. For Montana, there are 2 of them. There's 1 Texas. I'm in there now. If you don't add me, you go through this exercise, you don't add me or somebody like me, you won't have any Texases. That's totally fine. Most of them are in Washington in this case. So we're asking a pretty interesting aggregate function. Again, not changing anything behind the scenes, just asking questions about what we're seeing behind the scenes. Now, you've seen in a couple of these that the top of your column for these aggregate functions often doesn't have a title. It says no column name. This is going to show up in maybe even the very next slide. But if you want it to have a column header, you can add as, and I could do something like region count. It's anything I want. It's anything I make up. It's not already used someplace else. And when I execute this, it will add a nice header for your column if you want. So as is basically an alias for a field. And you can do it for anything. You can do region as RG. I don't know why you would do that, but you could. And then you can see that you've basically given that column a new nickname. It is particularly useful for when you're doing aggregate functions because they don't have a default name. But if you want to rename a column to something else, you absolutely could. So as an example, if I think about the exam problem where we had various nations that were participating in matches, that was that problem where we did the various nations participating in matches. It's entirely possible in our table, the way we would code those is nation ID and nation ID for visiting and for home. But you might use as and say home nation, and as and use visitor nation to differentiate between those two. That's entirely possible. So something to think about there. Okay. So group by, basically doing subgroupings and then doing aggregate calculations for those subgroupings. Group by is extremely handy for those kinds of calculations, and we do them a lot when we're asking questions of our data. If you have a group by, instead of using a where, you can use a having. Having acts like a where clause, but it is for the grouping, not for the overall query. So a where would be, for this entire thing, we're looking at a specific criteria. The having is for individual criteria within the grouping, what's the criteria that we want to match up on. So this one, again, you get to a point where you should be able to kind of read these things and say them out loud as a human being. This one is going to count up the various regions in our customers table and report the number of regions for each region in that table, but only if there is more than one of that region. So I have the results of my previous query up on the screen right now, but you can see that a bunch of them are small. Utah, Texas, and Quebec each have one. If I run this query, because of that new having clause, those three should disappear. And we get down to just regions that have two or more, right? More than one, two or more for the count. So if you want to narrow the scope of a aggregate function that uses a group by clause, you can use a having clause to add additional criteria. I'm giving you these queries that are already preformed. The challenge to all of this is reading a real world question and coming up with the appropriate query that gives you the results. And especially when we get into these aggregate queries, the first couple times you guys play around with this will be really challenging, coming up with some of these queries. Some are easier than others, but some of these, especially with the group bys and the havings or the order bys or additional where statements, can be really difficult. And every query that I've demonstrated so far is only looking at results from a single table. But we're going to get to a point where we start to ask questions of multiple tables and combine those views of multiple tables to get interesting results. And obviously that gets a lot more complicated as well. So something to think about there is these will get even more complicated than everything I'm demonstrating today. Last one, this is where I already demonstrated this, but if you want to, at any point, you can give an alias to either a column that already exists or some sort of calculated column by just using as, and it will report that information with the new header to basically that you have chosen instead of the default. So I can change it to name and state and output it, and that's totally fine. Yeah. So quick view of lots and lots of different types of queries, but watching me do it, not remotely as beneficial from a learning perspective as doing it yourselves, which is why I'm asking you guys to work through a lot of different queries in the workbook. So I'm going to keep today kind of short, but I'm going to encourage you, even today, you could right now, if you're not remoting in, start working through some of those questions in the workbook and see if you can get information out of the various databases. Now, I've given everybody plenty of time to get those databases set up in SQL Server. If you are still at a point where you're not set up, that's on you at this point. I've given you an opportunity to visit with me if you needed to, but everybody should have these databases set up in SQL Server. If you are remoting in, wait until sometime this evening or sometime in the morning later this week. But I would start working through those queries. And then if you have any questions, if you can't figure this stuff out, you guys know where to reach me. Yes? So that's it for today's lecture. I'm going to stop the recording and then I'll stick around and answer any questions you might have.